it's going to be important to be able to describe and to define that matter. So we're going to need some important descriptive terms in order to help us understand different types of matter, the descriptions of those types of matter. So one of the easiest things to start out with is to describe how large matter is. So we're going to talk about large things versus small things today. Large things versus small things. If you have two boulders, one large and one little, and I just asked you which of these would be easier to move, intuitively you would say the green one on the right-hand side is going to be the easier boulder to move. It's got less stuff. As you take a look at the picture, it's got less stuff, it's smaller, so it's going to be easier to move. And sure enough, when you push them with the same force, the green boulder moves a lot faster than the black boulder. We actually have a term for this that we use in a physics course. You don't hear it so much in chemistry, but you do hear it in physics, and that term is called inertia. Okay? So inertia just means that large things are really hard to move. They're harder to move than smaller things. And in fact, inertia is things want to keep their current speed. So if they're stopped, they want to stay stopped. And if they're going, they want to stay going. And the bigger those things are, the more they want to keep doing those things. And so another term for inertia is laziness almost. Inertia and laziness go hand in hand. If something's got a lot of inertia, it's pretty lazy. So my question off the bat would be, if something has a lot of size, if it's very big, is it always lazy? Let's take a look at that. Let me have a big cube over here. A big rectangular cube. And that big rectangular cube is going to be made out of styrofoam. And on the right-hand side of that cube, you're standing and you're going to catch that cube of styrofoam. All right, so I'm going to throw it into the air and it's going to be up to you to catch it. Now, it may be a very large piece of styrofoam, but it's very easy for me to project up into the air. And all in all, it's going to be relatively easy for you to catch as well. So you actually are a happy human being. You've caught the styrofoam. Let's look at another instance now. I say, very good, you did an excellent job, and I bring out a second piece of matter, and it's a lot smaller to your eyes. And you say, my goodness, that's going to be a piece of cake to catch. Here's where it's going to be important for you to understand the symbols on the periodic table. So I rear back, and I give this thing a toss into the air, and it's nice and high, and it's arching, and it's arching, and it's arching. And at the last instant, you remember from 8th grade physical science that, oh, PB means lead, and as it's coming down, it hits you on the top of the head with a lot of force, and, well, bad things happen. All right, so even though the styrofoam looks much bigger than the lead actually has more inertia. So we just can't take a look at something and actually say, well, it's bigger, because there's so many different ways that you can define bigger. You'd have to say, well, Mr. Cornick, what do you mean by bigger? And bigger dimensions, or one has more stuff than the other. And that's a key term that we're going to look at next. So the lead cube is going to be harder to move because it's got more stuff. The lead cube has more stuff. And by stuff, I mean more particles. And we're going to get into that a lot more later on down the road. But the lead's got more particles packed inside of it than the styrofoam does. Okay, more stuff just simply means more mass. So if you hear me say stuff, it means mass. All right? So stuff and mass. So we know that the lead's got more mass, it's got more stuff, it's going to be harder to start moving, it's going to be harder to stop moving. Now, how do we measure this? I said this is an important quantity for chemists to be able to measure. Well, back in France, and you can kind of see this with the recording there, back in France, they actually have a place where they keep a lot of these standard weights in Sèvres, France. And this is actually where the blue arrow is pointing. That is a 1 kilogram piece of platinum. It's been hanging out for quite a while under a vacuum. And scientists have gathered around it and they said, that thing right there has a mass of exactly 1 kilogram. And so everything else is compared to that. Okay, everything else is compared to that 1 kilogram standard. Now that probably doesn't mean a lot to you because you can't get a good visualization of that particular piece of material. This might be a little bit clearer. A large apple, like a large Gala apple, has the mass of about 1 kilogram. Okay, so that might be a little bit more visual for you. So the kilo is the standard unit for measuring mass. It's actually a pretty big unit. the kilogram. In science and chemistry in particular, we often work with really small things like atoms, molecules. So we want a smaller unit than the kilogram, so we often refer to something called the gram. 1 gram equals 0.001 kilograms. It's kind of weird. It's a little bit easier to visualize. 1,000 grams equals 1 kilogram. If a kilogram is an apple, approximately, a gram is about a paperclip. To give you a nice little visualization of that. So how do we measure these things? Well, we've got a couple of different ways in the science classroom, the science laboratory. We're going to have a scale, which you see on the left-hand side. You also might have a scale in the bathroom. The scale actually measures your mass, does a quick calculation inside, and gives you your weight. Mass, weight, two different things. Please don't goof up kilograms and pounds. Very different. On the right-hand side, we've got a balance, and you're going to start out using balances this year to get an idea as to how things are measured precisely and exactly without the help of the electronics that we see on the left. Okay, so obviously, if we put the styrofoam on the left-hand side of your balance, there's the styrofoam, and we would put the lead on the right-hand side of the balance. I think it just disappeared on me. Come back here. There it is. The lead on the right-hand side of the balance. Let me redraw our balance here. What would happen to our balance? Well, even though the styrofoam might have a bigger area, it looks like it's just a larger object, the lead in itself is actually going to tip the scale. And the scale should tip in the downwards direction. Okay. So a measure of the stuff a material has, that is mass. Mass is a measure of stuff that a particular material has.